This tutorial will demonstrate how to find the roots, the axis of symmetry, and the vertex of a parabola, all through algebraic methods. The first thing we'll find are the roots, which are also known as the solutions, or the zeros, or even the x-intercepts of a parabola. We're going to use the zero property here, and we only have to find factors of 3 that add up to 4. Those would be positive 3 and positive 1. And due to the zero property, we know that either that first quantity or factor or the second factor would have to equal 0. Inverse operations for each one would show us that our roots are at negative 3 or at negative 1. Since those are x-intercepts, we would go over to negative 3 and negative 1, and we know that our parabola goes through those 2 points. The next thing we'll find is the axis of symmetry. Now what the axis of symmetry is for any parabola, there's some imaginary line that would go down the middle of it that would split it in half. And it is a vertical line. That's why you'll notice that the equation is the form x equals. We find it by using the second coefficient b and the leading coefficient a. And the b is 4 in this case, so the opposite of b is negative 4. And in the denominator we'd have 2 times the a value, and the a value here is 1. This would give us an axis of symmetry of negative 4 over 2, which is simply x equals negative 2. We'll go to the graph, and where negative 2 is, we can draw an imaginary line, and that's going to go right down the middle of our parabola. And it's no coincidence that it is equally spaced from the 2 zeros. The last thing we'll find is the vertex, and what I've done is I've already written the equation down, and since completing the square is going to give us a new c value, I've kicked the old c value out and we made room for a new c value. To find that, we're going to take the b value, which is 4, we're going to divide it by 2, and then we're going to square it, which would give us 2 squared, and our new c value is 4. So we're going to add that 4 in there. And as with any equation, we have to keep it balanced. So since we added a 4 on the right side, I'm going to undo it by taking that 4 away. And what we're going to get here when we simplify this is we created a trinomial perfect square. The factors of 4 that add up to 4 are 2 and 2. So we get that perfect square binomial. And since we had the plus 3 and the minus 4 at the end, those combine to give us a negative 1. And as we know by interpreting our shifts, the vertex would be 2 to the left and 1 down. So our vertex would be at the point negative 2, comma negative 1. Plotting this on our graph, go over 2 and down 1. There's our vertex. So a quick sketch of the graph would be a parabola that roughly looks like that. It would be a lot better if I wasn't writing it on the iPad with my finger. The other example you've got here is x squared minus 3x minus 10. If you'd like, you can try to find the roots on your own and just pause the video, and that way when you unpause it, I'll show you the results. The roots are found by setting it equal to 0 and then using the 0 property to factor. The factors of negative 10 that add up to negative 3 are negative 5 and positive 2. And this would, by setting each of these equal to 0, this would give us results of positive 5 and negative 2. And we'll put those on the graph, and we know the parabola goes through those 2 points. Now to find the axis of symmetry, we'll use the formula again, where we use the opposite of the middle coefficient and then twice the first coefficient. Now our middle coefficient is negative 3, so the opposite of negative 3 would be positive 3. And in the denominator we have 2 times a, which in this case would be 2 times 1. And our axis of symmetry is at 3/2, or 1 1/2. We'll notice that is right in the middle of the two roots that we already found. So 1 1/2 would be right there. So we'll just do a nice vertical line, doing it dotted because it's imaginary, and that'll split our parabola right in half. And again, you'll notice it's equidistant from the 2 roots. It's 3.5 spots away from each of them. The last thing we're going to do is convert this to vertex form. So right now we have the equation x squared minus 3x minus 10. That minus 10 isn't the c value that makes it a perfect square, so we're going to kick that out. We're going to find our new c value by taking the b value and dividing it by 2 and then squaring it. Now this would give us a new c value of 9/4. So what we'll do is we'll put the plus 9/4 in, and we have to undo it, so we'll also take a 9/4 away. One thing to remember for some of our calculations is 9/4 would be equal to 2 1/4. Now just with a little simplifying, the perfect square that we created is going to be x decreased by 3/2, and that's all squared. The easy way to find it is just to look when you created your new c value, and that b divided by 2 would be the second part of your binomial. And then we had a negative 10 take away 9/4 at the end. That would be really like a negative 10 take away 2 1/4, so that gives us a minus 12 1/4 on the outside. Our vertex, therefore, is going to be the point positive 3/2, and we get that by knowing that's a shift of 1.5 to the right, and the negative 12 1/4 gives us a vertical shift downward, and there's the vertex. So a little funky to graph. At 1.5 is where we go over, and then down 12 1/4. Now in our graph, don't really have enough room for it, but the vertex would be way down below off there. So this would be a graph that opens upward, and it would be pretty steep to get down there to that negative 12 1/4. Hope this has assisted you in finding all these different pieces. Remember, you can rewind back through, pause at certain times if there's any certain step you need a little more help with. On the sheet that it goes along with this video 1 through 6, there are a decent amount of fractions, and not everything works perfectly like you'd hope. So make sure you're sharp with those fraction rules, and the answer key for today's sheet is also on the website.